Hi everybody, hope you're having a great day. Today I'm going to show you how Kagoshima demo scene is created and streamed by our newly released TerraLand 4. I recommend watching our previous TerraLand 4 videos if you would like to know what each parameter does. This is a digital twin of a real-world location at Kagoshima City at Japan, but in fantasy style. Okay, let's start by explaining TerraLand 4 and explain how the scene is created. First, head to the top toolbars and select TerraLand 4 under TerraUnity menus. After selecting TerraLand 4, this window will be opened. We are going to explain how the scene is created. First tab is the Profile tab. As you see, the current loader profile is Kagoshima Fantasy. Profiles will save all the settings and parameters so that you can load them later for extending your options. The second tab is the Generate tab, where you define the world area and start downloading the needed data from the servers. In this tab, first I'm going to explain static terrain section, which is in this case used for generating background terrains. As soon as you select static terrain, you will notice that all the other tabs are grayed out, since they won't be needed in an editor scene with no streaming in place. We will set the area size to 100 square kilometers for the background terrain area. Since we are going to set an arbitrary tile grid value, which defines the total number of terrain tiles, we'll uncheck the WMS Tiles option, which I'm going to explain later. Set the tile grid value to 4 so that 16 tiles will be created, but feel free to change this value to your liking based on your requirements. We will set the height map resolution value to 4096 for each tile, so that we will end up with 16,384 pixels as the whole area resolution for our background surface. Since Create Satellite Image is turned off under Advanced Settings, which will be explained later, no satellite images will be downloaded and generated. We will use a custom terrain material on the tiles, which does the texturing and colors automatically. As said, one of the key features in TerraLand 4 is that you can insert your own custom terrain material, which in this case, we created a material which generates colors based on terrain slopes on GPU. Having this material, you no longer need satellite images or splat maps on terrains. After pressing the Generate button, the background terrains will be generated in scene hierarchy. Please note that this can be your final step for your base environment generation, but in this case these terrains are only used for background covering and far viewing distances where the streaming terrains will be loaded on top of them in game mode. Okay, let's turn the background terrains on and off in the scene so that you will get the idea. Okay. Let's move on to the more exciting part of streaming, where this time, terrain tiles will be created as prefabs automatically and being put in a streamable server for runtime streaming. Now, let's select the streaming mode to reveal the options for server generation, and you will see that all the other tabs and options are activated again. For this time, we will set the area size for our main terrains area to 50 square kilometers. We will use the WMS Tiles option this time, which is a one-to-one representation of distributed data on tile mapping servers as the standard protocol for geospatial data servers. In this case, you won't need to define grid tile or total number of tiles, and TerraLand will automatically pick the best settings based on connected servers, such as Esri. Here we set the zoom level value, which defines the total count and resolution of the obtainable data. We will set it to 14 as a balanced value between quality and performance targeted for our scene, which is the equivalent of 625 tiles as shown in the info box below. In other words, our server will have a total of 625 word cells or chunks distributed internally. As for the main terrains, we will also disable Create Imagery texture option since we use the same material as background terrains. This way, there is no need to download, import, generate, and stream satellite images, so anything from word generation time to runtime streaming will be faster. Also, please note that this behavior is based on fantasy style graphics we are aiming, but you may need to have this option enabled for your photorealistic or GIS scenes. If it is the first time that the server is generating, the button shows Generate Bundles. But if you're updating a previously generated server, then the button shows Update Bundles, as in this example. By pressing this button, TerraLand will collect all needed data from servers and generate word cells for you. It may take some time to generate the server based on the area size and other settings you set in the profile. Terrain streamer component is the medium between your scene elements and the streaming chunks on top of it based on the distances you set for the layers on it. These layers are the equivalent of the Unity layers you define for your streaming entities in your project. Under layer settings in Terrain streamer, you can specify the distance from the camera in which the layers start to get rendered and shown. We will extend this layer system in TerraLand so it is one-to-one to defined layers in Unity. As you can see here, I changed some of the layer distances so they will be picked during runtime for rendering different layers in the scene. Here are all the layers we used in this demo scene inside our project. Now let's head over to the editor tab, which lets you load specific tiles from the created server so that you can edit them inside Unity editor and to add items like trees, rocks, buildings, particles, effects, and etc. into your world. I want to edit part of the world where my player and the base is located, and since I already know what tiles to open, I'm going to select some surrounding cells to edit them as well. You can see the selected and the unselected tiles and their count in the info box down below. Once you are done selecting the editing tiles, press the button Open in Editor. Now you can see all the loaded tiles with their corresponding items under PrefabHandler. Okay, time to add some new 3D models next to the base in the game. When we want to add an object to our trains, we have to place the object under the exact same train in the scene. So let's check which tiles need to be filled with our items. In the next version, we will use a raycasting technique to automatically pick the underlying train when placing the objects in the scene. Now that we found our tiles as word chunks to edit, let's place some new objects. We are going to use some prefabs as word objects from Polygon Cypher Words assets made by Scene2 Studios. Now let's place the objects under the corresponding trains in order to be part of that word chunk. Here you can set up different layers for placed items, so TerraLand can divide server bundles based on them and set up different options in each layer in runtime. I'm going to assign building layer to all of the placed structures and assign biome layer to all of the plants in order to specify different streaming and rendering distances for each one of these layers. When you are finished with editing and placing items on the trains, you have to press Save and Update so that all changes and additions will be uploaded back to server. You can also press Close Editor if you don't want your changes to be updated. However, you can always load word chunks via Editor tab again and continue with your level design. Check if placed objects are part of the server now. Let's select and reopen previously edited word chunks in the editor. As you can see, all the placed objects are saved in the server and are placed on their exact same spot that they were placed earlier via editor mode. Now let's head over to the Build Server tab in order to create the streaming server. We can set the location of the publishing server to 3 types of built-in, local, and remote. Built-in means the server will be embedded into Scene Build so that you can share the build game, which already has access to the server internally. Local mode lets you select a location on your hard drive so that the server will be placed there. The best use case for this is selecting a location which is under your LAN network, so that players can have access to the server on your local host. In remote build, the server content will be saved somewhere on your computer so that you can upload the server on your online hosting space, and players from any location in the world can play your game, as the word content will be streamed from your host server on demand for players. We use the remote build mode for this demo of Kagoshima 2, and you can always update your server and publish it again, and players will be updated with the new word content that you pushed on your last server update. Now let me show you how remote build works. First, we need to select a directory on your PC for saving server content and included bundles. Press Build Bundles if this is the first time building the server, or Update Bundles button if the server is already created, so that changes will be patched into the master server, as in our case in this video. This is the folder which you need to upload into the defined address in the build tab, which is somewhere on your online host directory. Now let's try the built-in mode publishing so that I can show you the world with our changes made in this video and see our newly added content on top of the previously created server as an update patch. One last thing to do before testing the build is to show you other components and objects in the scene which serve as the foundation of the world environment and include game design and scenario scripts and items which is separate from the build server made by TerraLand. We have specified different zones on the map in order to place different objects based on these zones, and set runtime scatter volumes for more varied and scenario-based placement throughout the entire map. In order to fill in the scene with 3D models, we took runtime spawner components from TerraWorld and extended them to place objects procedurally on streaming trains and world chunks. These scripts are already included in the package. On each runtime spawner component, you can add your own prefab and modified rules and conditions for placement, which happen in real time, both in the editor and in game mode. Using runtime spawners, you can define various placement zones via its volume layers option, where you can create volumes in scene and give specific Unity layers to be detected while placing models and prefabs throughout the entire world scene. There is also an option called Invert Volumes, which you can do all sorts of placement exclusion or inclusions based on defined Unity layers. In this demo, we use volume layers feature to set up a zone called City Center around Kagoshima volcano in order to let runtime spawners know which prefabs need to be placed inside or outside these zones for a more varied and lively environment. Now let's build the server in built-in mode. Finally, here's our built game. Let's play and have fun.